What's up, coders? Today we'll discuss lead code question number 1462, course schedule 4. Here we are given a total of num courses that you can take, which have indices ranged from 0 to num courses minus 1. Also you are being given an array of prerequisites where each prerequisite means that, let's say the prerequisite is AI comma BI. So it means that course AI has to be taken before course BI at any cost. Okay. For example, we have one prerequisite as 0 comma 1, which means that we have to pursue course 0 before course 1. Right? This is the condition. Okay, great. Also, it is given that the prerequisites can be indirect. So let's say we are given two prerequisites 0 comma 1 and 1 comma 3. Now we are given 0 comma 1. It means that course 0 should be taken before course 1. Also course 1 should be taken before course 3, which implies that course 0 should be pursued before course 3. Okay, this is how prerequisites are indirect. Okay. Also we have been provided a array of queries, and each query has two indices u and v. So for each query we have to answer whether course u is a prerequisite for course v or not. Okay, let's take example number 1. We are given this input. We have two courses, one prerequisite and two queries, right? So here prerequisite given is 1 comma 0, which means that course 1 should be pursued before course 0. Okay, also in other words, course 1 should be pursued first, and after that course is completed, only then we can pursue course 0 afterwards. Now we are given two queries, 0 comma 1 and 1 comma 0, which means that can 0 be a prerequisite for 1? So here clearly it is not the case. Similarly for 1 comma 0, right? For 1 comma 0, yes, this is indeed a case. Why? Because we have to take course 1 before course 0, right? So the answer will be an array false comma true. Okay, great. Similarly we can also answer for this. Okay, we are given two queries, 1 comma 0 and 1 comma 2. Okay, great. Now for 1 comma 0, is it such that 1 is a prerequisite for 0? Yes, because here, as you can see in this part, we have to pursue course 1 first, then only we can pursue course 0, as you can see in this array. Okay, 1 comma 0. Okay, great. Similarly for 1 comma 2, it is also the same case. Now how can we pursue, now how can we approach with this question? Okay, so what can I do is, let's say, okay, before going towards the approach, let's go through the constraints. We are given only 100 maximum courses allowed, and the length of the prerequisite is this number, which technically means that maximum number of joins we can make between any two courses. Okay, great. So it means that we can assume that this array might contain all the possible connections between any two courses. Okay, fine. All the pairs of prerequisites are unique. Okay, great. Also this graph has no cycles. Let's discuss what this means. Okay, in this drawing tool, let's say I have a course A and course B and course C. Okay, so if we had cycle, which implies that course A should be taken before C, which should be taken before B, and this course B should be taken before A. which is technically not possible at all, right? Because if each of these courses is dependent on the other course to complete, so we cannot pursue any course out of these, right? So to prevent this conundrum, we are given this constraint that the prerequisite graph has no cycles. But you might wonder one more thing that can happen. What if we have some case like this, and codes D like this, okay, and we have the connections as such, like codes B, this, okay, and this and this. Yeah, now you might think this is also cycle, but this is not a cycle. Why? Because if I start from A, okay, D should be taken before B, sorry, D should be taken after B, which should be taken after A. Okay, great, this can be possible. Or and here also D should be taken before C, which should be taken before A. Okay, this is also great. Now if I pursue A first, after that I can go for B and C. These will be allowed, and then after completing both of these, I can finish course D. So this is not indeed a cycle here, because this makes a directed graph, and in a directed graph, cycle means something like this, right? This is a cycle, not this. This is not a directed cycle. Okay, great. Now how can we approach this question? Okay, now what can I do is let's first make a graph, neat little graph, like this, and maybe some points here and here. Okay, we have made the graph. Let's make some connections. Yep, this is done. This is 1 2 3 0 4 and 5. Okay, nice. So first what I can do is I can maybe find if I am able to reach from point A to point B, if this is even possible. Okay, so for that what I can do is maybe I can make a matrix like this. Okay, it might have n number of rows and n number of columns here. So in this case we will have 6 rows and 6 columns. Okay, like this, something like this. Okay, now I will what will I do is I will check whether from 1, for what nodes will I be able to reach. Okay, if say I am 1, will I be able to reach 0? Answer is no. Will I be able to reach 4? Yes. 5? Yes. 2 and 3, all these yes. Just for 0 it is no, right? So I will find this answer for all the possible pairs and just neatly update this table and so on. Now how to do this effectively? Okay, what I can do is I can start from each node. I can start BFS, breadth first search, from each node, and then check at what nodes will I land. Okay, let's suppose I am starting from 0. Okay, I am starting from 0. I can go to 4. Okay, great, 4 is reachable. I can go to 5. 5 is reachable, but this 2 is not reachable, right? So for 0 I can reach 4 and 5. Okay, nice. Now if I start from, let's say, 3. Okay, if I start from 3, I can go to 2, I can go to 4, I can go to 5, but 1 and 0 I cannot reach from 3. Okay, good. I can do this BFS for all the indices and then check. Okay, but there can form one more case where we might repetitively calculate these values. Okay, okay. In the same graph, what I can do is, let's say I am computing for 1. Okay, I am computing for 1. Okay, this 2 is reachable, this 4 is reachable, this 5 is reachable. Okay, great. Now I will also go to 3, right, because I am doing BFS. 3, this is reachable. Now from 3 I will go to 2, but here as you can see this 2 is already marked as reached, right? So we don't need to compute further from this 2. Okay, I will stop here. This is what we are gonna do. This is the crux of this question. Okay, after finding all the possible, let's say this array that we are going to make is reach I comma j, which means that if I can reach j if I start from I or not, whether I can reach from I to j or not. Okay, okay, cool. We can make this and then answer each query based on these values, and our question will be solved. Let's try this approach. Let's name this as num, and let's change the name as pre for shortening the code. Okay, great. First let's convert these connections into a graph. Yep, we have made the graph. Now I want to make that this array which will be named reach. Let's do that. In fact, let's split these windows side by side to ensure we understand everything. Let's do yep, we have done. Now I will start from each index and perform BFS as I explained in the approach. This will be the current node where we are standing in the BFS. If reach of I current is already there, so we will just stop going further from that node. But if not, I will mark that node as 1 and then go further from that node. I think we are done. We have now prepared this array reach, 2D array reach matrix. Okay, now I am ready to answer all the queries. Also this will be the answer. Let's also make vector bool answer initially set to false. Answer dot, no, I will just keep on adding values to this vector. And then return the answer. Let's try to run this code. Little typo here. Yes, all the cases got accepted. Now let's submit this code. Yep, our approach got accepted. Okay, great. Now let's summarize the approach once again, so it's even clear to you. It's even more clear to you. Okay, let's say I have this connections between the courses. Okay, so here these arrows means that if the arrow is from 1 to 2, it simply means course 1 should be pursued before course 2, and the connections are like this in any given input. Okay, great. Now what I will do is, first I will prepare a matrix reach. What this matrix will do is, it will tell us whether point I, course I, is connected to course J or not. So here 1 is connected to 4 or not. Yes, like through 2. Okay, yes, this is connected. So I will prepare this matrix. Okay, like this. Okay, now how will I prepare? So what I will do is, I will run a BFS from each node to the entire graph, and whatever nodes I come across, they will be marked as true with respect to the initial node. For example, if I am starting from 0 and I come at 4, okay, so 0 is connected to 4, so 0, so reach 0 4 will be marked as 1. Now I can also go to 5 from 4, so reach 0 5 will be also marked as 1. I cannot go to 2, so it will remain false. Now I have started from 0. In the same way, I will start from 2, from 4, 5, 3 and 1. Now one very important thing I want to discuss here. If there can be cases where I start from 1 and I might arrive at any other node multiple times. So I want to prevent that. For that, I will check if I'm coming at any node, and if it is if it is already reached from my starting node, I will not continue further. So I will check that. Okay, let's say I am at 1 and then I come at 2. Okay, it is marked as reached. Great. Now if I am at 3, which is marked reached, now from 3 if I go to 2, this 2 is already marked as reached. So I will not further do this. From 1 to we are continuing the search, but if I'm coming from 3, I will not redo all the search. Okay, so this is the algorithm. Now once I have gotten all the values, all the possible pairs for reach, I will simply compute all the queries just by looking up in this table. So this was my approach. I hope you like it, and please drop down any comments or any discussion you want to do with me. I would love to answer or learn anything. If you have for me, I would love to learn. Thank you so much. Bye.